orbital, the value of L for s orbital is L is equal to 0 since n minus 1 man. So S equals, L is equal to 1 minus 1, okay? So 0. So they are, as you can see, spherical in shape, and the radius of the sphere increases with the increase of the value of n. Now let's see the probability graph of your s orbitals. So this is the probability of the electron as you go farther away from the nucleus, okay, from the center of your atom. So for an ns orbital, the number of peaks that you can see is the n. Okay, so 1s, 2s, 3s. Ang 1 meaning 1 peak, 2 meaning 2 peaks, 3 meaning 3 peaks. So for an ns orbital, the number of nodes meaning kaning bottom nga part as labeled, okay? So where there is 0 probability of finding an electron. So that is your n minus 1. As n increases, the electron density is more spread out. As you can see, n equals 1 na ara siya sa my left. While sa n equals 2, okay, na naiburag second peak going to the right, n equals 3, mas nagka-spread ang peaks, okay? So your electron density is more spread out, and there is a greater probability of finding an electron further from the nucleus. Let's now proceed to your p orbitals. So what does your p orbital look like? Your p orbital actually looks like this. Okay? So the value of L for p orbitals, so n minus 1, so 2 minus 1 is actually 1. You see 2 lobes with a node between them. Bura siya balloon nga naay burag gibutang lastiko sa middle. Okay, so that is your p orbital. Now, how about your d orbital? So na may forma sa d orbital. This is your d orbital. Mura siyag mga p orbitals nga gistick together. Okay? The value of L for a d orbital is 2. Okay, so n minus 1, so 3 minus 1, 2. 4 of the 5 d orbitals have 4 lobes, while the fifth orbital, it resembles a p orbital with a donut around the center. What about f orbitals? So it's too complicated, so I will not show here. It has 7 equivalent orbitals in a sublevel. So L ani n minus 1, f nimo is 4. So 4 minus 1, that would be 3. Okay, so now let's talk about the energies of orbitals in hydrogen. So, monit siya ang energies sa orbitals hydrogen. So, for a 1 electron hydrogen atom, orbitals on the same energy level have the same energy. And these are what we call degenerate orbitals. So, as you can see, n equals 1 shell, kani nga naa sa pinakaubos, it has 1 orbital. Now, the n equals 2 nga shell, it has 2 subshells composed of 4 orbitals. And n equals 3, naa siya 3 subshells, which is composed of 9 orbitals. So kada row represents 1 shell. And each cluster of boxes nga nakita ninyo, it represents 1 subshell. Bali, 1 subshell ng S, another subshell ng T. So orbitals in any subshell are degenerate, or they are called degenerate if they have the same energy. As the number of electrons increases, So does the repulsion between them. So what will happen to your orbitals, man? How would there be overlapping? So this is already how your orbitals look like. So there would be increased repulsion between them as your number of electrons increases. Therefore, in atoms with more than one electron, not all orbitals on the same energy level are actually degenerate. So orbital sets in the same sublevel are still degenerate, and energy levels start to overlap in energy. So for example, your 4s, you can see 4s, it's lower in energy than 3D. Okay, so more or less, ang imo expect 3D first before 4s, but because of this overlapping of energy, then your 4s is lower than 3D. There is another quantum number which is also significant. This is what we call your spin quantum number. Your spin quantum number is denoted by M sub S. Okay, in the 1920s, they discovered that two electrons in the same orbital, they do not have exactly the same energy. So ang spin of an electron, this is what they attribute to the magnetic field. Bali, ang spin sa electron, they use this to describe the magnetic field, which consequently affects its energy. This led to the establishment of the spin quantum number, M sub S. So there are only two allowed values for the spin quantum numbers. That would be plus 1/2, and that would be negative 1/2. So for Pauli exclusion principle, Pauli exclusion principle states that no two electrons in the same atom can have the same set of four quantum numbers. At least, sa ilang spin quantum number pa lang, you can see nga pwede siya plus 1/2, but ang pair niya would be negative 1/2. So, more or less, at least one nga of the four quantum number values will be different. And this, consequently, this dictates that no two electrons in the same atom can have the same exact energy. Now let's go and touch electron configurations. This is visible sa inyong periodic table. So to understand your periodic table better, let's have electron configurations. The way electrons are distributed in an atom, that is what you call electron configuration. The most stable organization of the electrons would be at the lowest possible energy, which I talked about this before. This is what you call your ground state. So each component, this consists of, for example, muna yung imong electron configuration. Okay? So 4p5. So kaninga 4, this denotes your energy level. This letter P, this denotes your type of orbital. And your fifth, the superscript, this denotes the number of electrons na naa sa orbital. So this is how you write the configuration, okay? NL, subscript nga number of electrons na nasa orbital. How do we create an orbital diagram? So, for example, we have lithium, 1s2, 2s1. So, let's create the box. Each box in the diagram represents orbitals. So, this is your 1s2, this is your 2s1. Half arrows represent the electrons. Okay, so you first fill everything with the spin up, and then, depending sa ilahang numbers electrons, you then fill in your pair nga spins which are opposite sa spin up. So spin down. So since 1s2 mani, you draw the down nga spin sa first nga box. And since 2s1 mana, you will not be drawing na the down nga spin sa second nga box. So the direction of the arrow, this represents the relative spin of your electron. So we also have what we call our Hans rule. So that's what we did kani sa Li, kani sa lithium. This is your Hans rule. So Hans rule states, Hans rule is spelled as H-U-N-D. Okay, that is how you spell Hans rule. So Hans rule states that when filling degenerate orbitals, the lowest energy is attained when the number of electrons having the same spin is maximized. Okay, same spin. So what we did, we first occupy all orbitals with the up spin before we occupy them with the down spin. This means that for a set of orbitals in the same sublevel, there must be one electron in each orbital before pairing, and the electrons have the same spin as much as possible. So taking account this, what about boron? Okay, so we have 1s2, 2s2, 2p1. Ang correct nga pag-write sa imong orbital diagram would be first, as according to Hans rule, fill everything with the same spin. And then fill them the the paired nga spin. So 1s2, 2, 2s2, and 2p1, since 1 naman ka-electron ang denoted sa configuration, you won't write anymore any spin. Elements in the same group of the periodic table, they have the same number of electrons in the outermost shell. This outermost shell ni mga electrons, this is what we call your valence electron. So for example, sa lithium, 1s2, 2s1, this is your valence electron. The filled inner shell electrons, that is what you call your core electrons. Muni ang imong completely filled na D or F sublevels. So in order to have a more convenient writing of your electron configuration, because as you progress, diba, as magkataas ang atomic number, magka-length, magka-long po ang iyahang electronic configuration. So we write the shortened version of it using brackets around a noble gas symbol and listing only valence electrons. So for example, manganese. Okay, so manganese has 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so taas na kayo siya. If we would like a more convenient way, we can write it as Mn. We can write it as Ar. The nearest noble gas of this is actually argon. And just write the kulang pa din 4s2, 3d5. Okay, so moni siya ang argon. Just write the remaining ng mga orbitals. That would be 4s2, 3d5. Sa inyuhang, how do you call this? Sa inyuhang periodic table, you can see nga naatay what we call your transition metals. Okay? So, muna siya inyuhang transition metals. Okay, so argon, again, atomic number ends in period 3. Its electron configuration is kanisha 1s2, 2s2, 2p6, 3s2, 3p6. So potassium, nga na atomic number 19, we would expect this to have electrons in 3D. Because di ba 1s2, 2s2, 2p6, 3s2, 3p6. Bali, ang sunod mismo, we have the d orbital pa man, so bali 3D. But ang 4s ang na-filled next. So these are what you call your transition metals. Transition metals follow the filling of 4s first by filling 3D in the fourth period. Okay? So we also have that is caused by the overlapping na sa imong orbitals at higher energy levels due to significant repulsion interaction sa imong electrons. Okay? So next, yes?
Kung saan pagkahibaw sa valence electron sa transition metals nga daghan sila sa tunga?
Naara na sa imong electron configuration. Okay, so again, as what I've stated, kung unsa ang pinakalas nga orbital, mo na siya ang imong valence electron. So for example, aning argon, so 3d5. The 5 electrons are actually your valence electrons. Okay? Okay na?
Yes, ma'am.
Okay, so continuing our discussion would be the lanthanized and actinized group. These elements fill the f orbitals and they have a special name and a special portion sa inyuha nga periodic table. So lanthanide elements, they are elements, usually atomic numbers ano nila is from 57 to 70. They have electrons entering the 4f sublevel. While in yung actinide elements, these include the uranium, plutonium. So they have electrons entering your 5f sublevel. So sa periodic table ninyo, okay, you have color-coded na sa mga modern na periodic table. So you have actually color-coded na periodic table. So these colors correspond to your orbitals. We fill orbitals in increasing order of energy. So different blocks on the periodic table, this correspond to different types of orbitals. So that is your S ninyo orbital, that would be the blue portion. P, kanang pink. The D would be your orange, while the F is your tan. Okay? So the S and P blocks, they are what you call kaning blue and pink na blocks. They are what you call your main group elements. The periodic table is followed directly when determining the electron configuration for most elements. Naapoy mga anomalies nga wala ni follow sa kanang nga trend. So these irregularities occur when there are enough electrons nga ma-half-fill nilang S and D orbitals on a given row. So for instance, let's have an example. So for instance, we have chromium. Okay. So the nearest noble gas for chromium would still be argon, and it has a configuration of argon 4s1, 3d5. Ang expected ani dapat is 4s2, 3d4. So nga nung wala man ta ni agi sa 4. This occurs because ang 4s and 3d nga energy, orbitals, they are very close in energy. And this occur in F block atoms nga nay F and D orbitals. So naa siya na repulsion nga nitabo, repulsive forces depending nimo sa imong atom that would want the electron to occupy the 3d5 rather than your 3d4. So, but most of the atoms, they just follow the trend nga mo 5 past 3d4, then mag 3d5, and so on and so forth. So far, any questions? Don't worry, class, medyo dili siya legible. Ako ang agi, but I will give you a handout that will be more detailed and more legible for you to understand what we just discussed right now. But so far, are there any questions or concerns? So I guess none, because wala na may nanubag. So I guess none, and I think we're only up to 4:30. So this would be the end topic kaning anomalies sa inyong periodic table. Okay, so please remember na we have a asynchronous discussion for Thursday. We will not meet sa Google Meet, but I'll be giving handouts and maybe some activity. Okay?
Okay, Miss.
Okay, thank you so much for response. And I think if wala na may questions and concerns, that's it. That ends our meeting. Thank you so much for attending and see you next week. Bye-bye.
Bye-bye, Miss.
Goodbye. Thank you, ma'am.
Thank you.
Thank you, ma'am.
Bye.
Thank
Thank you,
you, goodbye.
miss.
Thank you and goodbye, miss.
My miss.